The second thing I want to show before I show an advanced example is the fact that Elm is unidirectional. So on the right side here, this is a simple Elm program that you can get to from the Elm website. There's just two buttons, and these buttons will allow you to increment and decrement a number. So here, our main looks a little bit different. Most Elm programs will not just be a static page. This main basically says this is going to return a static page and there will be no reactivity. That's one option. Another option is to specify that your main program will have reactivity and that there will be a specific model and message going on. So message is Elm's convention for the equivalent of a Redux action. But it just by convention refers it to as message. And the way this works is with a basic program, you're going to give it a record where you give it an initial model, a view function, and an update function. So this is going to be a unidirectional architecture that's somewhat similar to Redux. So to dive into this, what I do is I create an alias for the model. The application's model is just a simple integer because that's all that's really required to maintain the statefulness of this simple view. I define a constant where the initial model is set to 0, and then I have a view function. Out of the box, these functions aren't actually annotated, and I like annotating these because it's helpful for me, and it actually helps the compiler out. So this view function is actually a function that takes in a model and returns basically virtual DOM. So for a given model, you see that div and the two buttons that you see on the right there. Again, the messages are really the actions. So there are two actions. There's a decrement action and an increment action. And then lastly, we have the update function. And the update function says for a given message and for a given model, let's return a new model. And that new model will be sent to the view function and re-rendered. So if we compile this should hopefully still behave okay. I have to include something in the import up here. Okay, now everything's happy again. So to really test the understanding of how this unidirectional architecture works, a good example of how to test this is to try and add a new button. So let's say we wanted to add a reset button. I want to be able to arbitrarily increment and decrement a number and then click reset and have it reset to 0. So let's go through this and see what it looks like. I'm just going to copy paste this and say I want a new button where the text is reset, and when that button is clicked, I want it to dispatch a reset action. This isn't going to work right away, but the compiler is going to guide us and help us fix this program now. So it says it cannot find variable reset. Okay, that's because it's dispatching a message, but reset is not defined in this union type, so I will define it there. We'll compile this. This is still not going to work because what the compiler is basically saying is in this update function, when we do pattern matching on the current message, we are only handling 2 of the branches, and the 3rd branch is not being handled. In just regular JavaScript, this would be kind of a default to returning undefined, but in Elm, there is no undefined, so we have to actually handle all these cases here so that there's always a successful return value. So when there's a reset action, I need to return a new model, and because my model is basically just an integer, I can just return 0 right here. We compile this. Now we see everything is type safe, everything is compiling okay, and if we click plus and minus and then reset, it goes back to 0. Click minus a few times, click reset, it goes back to 0. So this is a unidirectional architecture because we start with an initial model, we render the view with that model. When the user interacts with the view, it dispatches an action. That action is handled by update, which returns a new model, which then gets re-rendered. And so that's the unidirectionality of the program. So those are the 2 basic examples. Again, to do this sort of thing in Redux requires quite a bit more boilerplate, and honestly, it's just not as clean. You might be looking at this and think that this is hard to read. Again, Elm syntax is just a little bit different. Once you look at it and write a couple of programs for a couple hours, it really becomes not that hard to read. So I actually like kind of the simplicity of even just the unidirectionality of how Elm's architecture works.